we're going to be going over transformation rules. And this transformation rule, it works with any type of function that you could be working with. So this is like a linear, quadratic, all the way to absolute value. But first, let's look at this one quadratic function. Y is equal to a times x minus h squared plus k. So I'm going to be working from right to left, describing what each part of this function means and how we can determine what the transformation is going to look like based on what these values are. So starting off with k, we have that k is our vertical shift. And remember that vertical is up and down. So if we have that our a is positive, then we're going to be going upward. Positive looking up. And if it's negative, we're looking down. So we're moving downward. Then we can move on to our h. Our h, I like to tell my students, if you can't remember which one's which, just remember that h goes with the horizontal, leaving you with k being the vertical. So h will always be the horizontal shift. And the easiest way to determine whether that h is going to move you right or left is by determining what this expression, the x minus h expression, is equal to 0, then solve for x. So say that we have x minus h is equal to 0, and we want to solve for x, then that means that our x will be equal to a positive h, having us move to the right. But what happens if our x expression is x plus h, or x plus a value? Then that means our x is going to be equal to a negative h, moving us to the left. And then finally, we are working with a, and a is our amplitude or compression and stretch. Amplitude goes with the trig functions, and then compression and stretch goes with everything else, non-trig. All right. And like I said, this type of rule, this transformation rule, as long as you know what a, h, and k are and how to figure out the directions you're moving based on what those values are, you can be able to use this rule for linear functions, where here you don't have an h, because if you were to figure out a times x minus h plus k, your a times h function is just going to be a constant, which with that k that's also a constant, it will turn into just the vertical shift. So that's why we don't have an h here. Even if we did, it would turn into our vertical shift. Our quadratic function, we proved earlier. Cubic, same thing. Square root, same thing. Absolute value, rationals, and trig functions. Just as long as you know what k represents, what h represents, and what a represents, you can use that rule that we described earlier to figure out how the transformation is occurring from our parent function.